Welcome. Today we will explain that in pre-engineered structures we get STAAD Pro files which are looking like this. This open in Notepad. When engineers use STAAD Pro, they open these files geometrically and they can edit the command files like this. The structure of the STAAD files are very common, where people enter the data here and then they insert the joint coordinates. Then all the coordinates are described here. In initial stages they define the unit. For Indian pre-engineered building structures, the units are defined in the meter and kilonewton. In our system we don't need STAAD Pro installed in every system. We read the command files from server or through the software such that we can grab all the information from .std files, the STAAD Pro command files, and can generate the reports and can generate the DXF files to the scale such that handover documents are possible to prepare for detailers. It can automatically generate the Tekla importer files for Indian pre-engineered building structures, which are the custom parts of Tekla. And it can also generate the plated models if you want, that every flanges and waves are contour plates and taken separately. Sometimes people expect those kind of things also. Here we will show the demonstration how our software can work on this and how our software can help in the auto optimization and material tracking, and also for the initial drafts for the material planning systems for the purchase departments. Directly we can generate these things from the STAAD Pro files. We know that engineers have a big pain area. They need a lot of calculations to prepare these handover documents to the scale and to prepare the material planning systems from the STAAD Pro files, because there are several kind of profiles used as the tapered sections, and for tapered sections the flanges reports are different, wave reports are different. Waves are taper and with the polygonal shapes, and those are trapeziums with multiple thicknesses. And people who use STAAD Pro with the taper profiles, they know very well that how much time taking it is and how much error prone it is to prepare the material planning from the tapered sections, and also for the sections which are converted to the tapered. Suppose there is the box sections or pipe sections or many different kind of hot roll kind of sections, those are parametric sections. Our Indian PEB companies convert that to the tapers or plated models while they fabricate the objects, because of the 240 MPa or 345 MPa issues. The availability of plates is more in Indian PEB sector. So whatever the design conditions used, people prefer to convert everything as the plated structures. That is the big pain area in our Indian pre-engineered building structures. This software has the capability to do the material planning. It has the capability to generate the scaled drawings and also the Tekla importer, plate importer objects directly from the STAAD Pro files. And it has the capability to store the data in the server, in the datasys server. If you have the datasys ERP system, then it will automatically manage multiple revision version, multiple try versions of STAAD Pro in the project life cycle, such that you can compare the scenarios of different types of STAAD files at the different stages, date wise, time wise, engineer wise. We can compare the stage of plated taper sections used, and frame wise weights we can get those things. We can get the Z elevation wise weights, we can get the thickness wise weight report, we can get total surface area for sandblasting. We can calculate a overall estimate while we are doing the design works, and optimization works. It is very tedious to use Excel or some other formulation systems to generate the material planning, to generate the project costing planning from the STAAD profiles. This software works on all those things and can generate the estimates as per your configurable needs, and as you will ask, we will generate the configurable reports for you. Here we can show you that how can we do the work simplified for the engineers in the PEB sector. Let's show that how our software simply read this file, and in this folder you have seen that there is no other file present here. Now we will run our tool here to show you the demonstration. It is actually a part of SAGID, and it is actually the part of the DataSys ERP system, but many people use it separately out of the DataSys ERP systems who have their own ERP framework or who are using SAP. They can import our data to their own ERP systems or to their SAP systems. For that we need to configure the file formats as per the ERP standards people are using. Otherwise our system of DataSys ERP automatically takes the format as in our system. It automatically generates the files here, and from there you can see that it is saying that the DataSys system connection is not taken. We have stopped it to demonstrate it here. Now it is verifying those different servers, but after that we have given a license here to run it separately. It will open, it is checking that license. Due to the antivirus and due to the Windows firewall, it takes a little time. Now here you can see that we have the 2D STAAD files. For 2D STAAD file we can use this tab. For 3D STAAD file we can use the different tab, and it has the auto optimization systems also. Now simply we are trying to show you how to run it. For the first stage, this is the 3D STAAD file, this is the open STAAD file. Let's click here. It will ask for the folder where the STAAD file is there. We are pasting the path. Now it is the STAAD file as we were showing right now. Here simply click it. It is starting to read the file. Even the STAAD Pro is not installed in the system, it will read the command file as a text file, and it will generate the material planning systems. It is reading the data, it was preparing the data, and it is now reading it. It is saying that since STAAD nodes are misaligned to very small distances, sometimes the nodes are not aligned properly due to the way engineers split the members, or sometimes they put the nodes in a ungripped way. The snapped way are not used properly, so sometimes 0.001 millimeter deviations can occur, or sometimes 0.1 millimeter deviation can occur, and it enforces the linearization for those small errors through the tangent vectors, and it enforces the whole things to align it, and it generates another STAAD file where the alignments are done properly. This is one feature of STAAD Pro, because many people request to make the STAAD files in this way, so that if there is any deviation, the node positions readjustments are automatically done, and original STAAD file is kept intact. It prepares another STAAD file where it linearizes the members. Then it does the grid detections. It automatically detects the grids along X, it detects the grids along Y, it detects the grids along Z. The first thing first here is the pre-assumption is that XY plane, the XY plane is taken as the end wall direction, and XZ plane is taken as the side wall direction because our longitudinal loads and lateral loads are followed in this way. The end wall has a different kind of detailing, the side wall has a different kind of detailing in our Indian pre-engineered building structures, and if you need, then we can configure the whole things in that way. We have detected the XYZ alignments, we have detected the unique values of X, unique values of Y, unique values of Z, and it has automatically detected the support locations, it has automatically detected the release positions, it has detected the beta angles, and then it reads the data of the STAAD file. Node alignments done, and count of the corrections done in the node's coordinates is 38. That means in the 38 locations the node was misaligned in the to a little extent, not very far, but up to 1 millimeter or up to 3 millimeter distance the nodes were misaligned, not along the same line of the members, so they were adjusted as per the pre-engineered building standards, because the out to out distances calculations and in to in calculations, center to center calculations are all done in that way as per the PEB conventions. And then it has prepared another STAAD file, copy of the STAAD file, where it has corrected this. Now hot rolled found are like this, and if there are hot roll members present, then it detects that, and if necessary, then it converts that into the plated objects, such that the material planning for those are also taken care in the separate report. And it has found the pipe section also. It detects these things in the STAAD file and then converts it into the plated structures if necessary. It keeps a copy of the STAAD file with those kind of parametric plated structures, and then prepares the material planning. We have taken a very large STAAD file such that we can show you that what it is doing. It has generated one report here, that is the cleaned STAAD file. First of all, it has generated this Excel file also, and I am explaining you one after another. It has generated multiple reports here. Let's explain the reports here to you. Here in the first report, you can see that it has generated the handover sketch tabular report. It represents that how many of these tapers are found. These taper IDs are given, the rotations, beta angles are 0, 0, 0, and so these are all shown in that way. The WD1 means wave depth 1, WD2 means the wave depth 2. For every member there are two types of wave depths. The wave thickness is 4 mm thick, top flange width is 172, top flange thickness is 6, bottom flange width is 172, bottom flange thickness is 6. And for STAAD Pro, in the tapers, the top flange thickness plus bottom flange thickness plus wave depth are taken as total depth, and it auto calculates these necessary things, and it reports the tapers or the different kinds of tapers used in this file. It has given its description. It is one report. In another report, it is showing the different load cases, and overall kg per meter in the tapers is this. This is important for the marketing team, for the sales team. This is the report for the sales team, where total delta x found, total delta y found, and overall meters of the tapers are these. Overall kg of the taper is this. This is a single point report for material planning. It is showing it here. Then it comes with the other reports. Here in the same folder, you can see that it has generated one MDB file, and also it has generated the member cross section verify report. We will explain all the things one after another. The tapered single checking report is here, which we have already tried to show you, that this is the report where initially it says the total taper weights used, and in kg and also in kilonewton. total tube weight found and total tube weight from the members, because the tubes were not found here, so it is showing like this. Overall kg per meter, that was reported here. Total thickness, for the thickness 4, it is giving you the explanation regarding the web total, top flange total, bottom flange total. For every member wise it is giving the report, and overall the data are coming here for every tapers, how many kg per running meter are coming, what are the optimization scenarios, and it gives a detailed report for everything with the calculation breakups. And at the end it gives a report for the grids automatically generated for the drawings, and then it shows the still takeoff. Before still takeoff, it shows you the kind of reports that you normally send to the marketing team, and for the production team it generates this kind of report for the engineering verification, engineering review. This is one report, which is the Sagirid framework for PEB tapered and cleaned STAAD file with these kind of reports are there. Now in the second report I want to show you here. This is already opened in the Excel, that I will explain you. In the third report, here you can see this report I have already shown you. In the fourth report, it shows the breakup of the tabular data for materials used. Suppose in this STAAD file, thickness 4 is used for taper, and for tube, if the tube was used, then it could give a separate breakup, how much of the plate, if we convert it to the plated structure, then how much of the weight is used there. 4 mm thick, 5 mm thick, 6 mm thick, 8, 12, 14, and if more number of thicknesses are available, then it will give that report here, the tabulated data. This is for the material planning, for the production team, and for other purchase team. These are helpful. The total number of thicknesses with the different number of members. This is for the member selections in STAAD Pro. When we use STAAD Pro, and if we want to check all the members which has top flanges, the 8 mm thick, then you can simply select it, and in STAAD Pro you can select from the material list, and you will select those members only where the thicknesses are these. Because for different scenarios, engineer expect to get these kind of selection filters. Those are not directly available in STAAD Pro, mainly for the PEB tapered sections. These reports are necessary for the optimization purpose. In this report you can see the detail of the tapers that we have already shown to you. These are the reports which automatically opens, and MDB is for the datasys server. It automatically carries the data of this current optimization stage or current revision stage. Now we should explain it here with the Excel file, what you get here. Now we will explain you with the Excel file, that is CSV file, which you can open in OpenOffice also. This automatically generates from the STAAD file, and I am trying to explain you the data you have found here. Member ID are here, and this member iteration property, these are the member iteration for the property. The total member in the STAAD 274, these are member numbers. The member count, these are done as per the conditions found there, because for different situations from member count 4 to 10, those are not taper objects, those are the other kind of hot rolled kind of sections, so those things are skipped here. And when we will see this skipping, then it means that those are non-taper objects, so the jumps are there. The property ID used in this STAAD Pro are to report here, that we have not taken here because it is taken out from the datasys server. the start node and the start node degree. Degree means the valency of the node, because a number of members attached to that node. It is also a special kind of report because these are used for connection design, that is geometric junction theory. It uses this report, this value, to understand which kind of Tekla connection to take automatically. Suppose sometimes you will need the 184, sometimes you need 189, or sometimes you need the connections of 146, which depends on the degree of the nodes present in the STAAD file. The final node number is here, and here you can see that for the STAAD member the unit vectors are calculated. These unit vectors are important because without these unit vectors you cannot decide the front side of the profile is connecting with the left side of another profile or not. These unit vectors of the members is helpful because for optimization systems also the local x, local y, local z are calculated with these unit vectors. And member angle planes are important for auto detailing, and these data are all prepared from the STAAD file itself. And even the server data are not found, it has the calculation with itself. It can calculate the moment of inertia of the sections. It has its own database to grab the data from the section profiles, section databases, and it prepares all the members data for all the members. It parallelly writes its member ID, its taper properties, the start point, start depth, end depth. For every member it is reporting the nature of its depth, nature of its valency, and here you can see the structural properties of every members. To all the members structural properties are listed here. It is not only the taper property, it lists all the properties from the taper data. The start depth, web thickness, final depth, top flange width, bottom flange width, everything are taken just beside the members. If the STAAD file has, here you can see, if the STAAD file has 490 number of members, then for every members it is writing the complete detail beside its entry, and all the detail are kept here in the row. STAAD Pro don't give this kind of reports in one go. One more interesting thing is here you can get another interesting thing which is very important, that is it automatically generates a drawing file. It automatically generates a drawing file. Suppose total STAAD lines in this way. When it will complete, now it is generating the drawing files. It was running, and before clicking here I went there to show you the 3D STAAD files. The sketch is done and it is showing the analysis file is not found. So it is saying that the STAAD file is found but .anl file is not found, .bmd file is not found. So it is saying that the analysis is not run. If it finds the analysis file, then in mdb file it stores all the end reactions, and you can copy and paste the end reactions into some text file, and you can call that for auto optimization with the fx, fy, fz, mx, my, mz. You can do those optimization calculations here. Now from this path I will try to show you this dxf file. This is also auto generated here. Now in the date modified report I want to show you that this is another text file generated, but here it is not describing everything because it could not find the previous revision in the datasys server, because datasys server is bypassed here right now. And now we will try to show you the dxf file which is automatically generated. From in this path we can show you the dxf file which is automatically generated from this STAAD file. That will help you to understand the feature of this software. And this is one interesting feature here. See, whenever the grids are found, it has automatically calculated the unique values. Here it is showing that grid Z, along the Z direction, the building is getting its frames, and for every frame it is writing the member number in the STAAD Pro, and to the scale it is showing you the distances here. Suppose here we can show you here we can show you the web. The flanges are all done in thickness, or the properly calculated. The webs are also properly calculated. If there are tapers, then one side, the outside is aligned properly. Its nodes are also represented here in the small green color. The start is this with the Z value of 13, and Z value means the not structural engineering Z value. This is the Z axis coordinate, that is a 13 millimeter. At the 13th millimeter, Z is shown here. Now in the next frame, the Z value is taken as the 20th, that is the 20th position of the Z value, the 20 meter, 13 meter to 20 meter, these are in the meters, and total frame weight of 20 meter is this much kg, and it is giving the breakup of every members, and it is giving the scaled drawings. This is the handover sketch for our modelers and detailers purpose, such that every different kind of member detail are shown here below the frames, so that you can give the GA drawings very fast. And frame wise it is giving you the complete breakups, so that you can communicate with your clients. These are the member details, and these are handover sketches automatically generated from the STAAD Pro. In this way, whenever the columns are there in any Z value, it is showing the columns also, and it is aligning the data as per the present conditions, and its outside is aligned. If you test it with the other kind of tapers, then you can see I have made a one taper very odd. I'm trying to show that I have placed one odd taper to generate this. If we instructed it to generate this on inside, then it would generate the data inside. Here it has generated it inside, here it can generate it inside. We have instructed it to generate it outside. These are the Sagirit commands, which we will explain in separate video. Now these are the kind of outputs. If we ask it to align this outline in a single straight line, then it will do. These are the special instructions to the Sagirit, with which we can generate the scale drawings directly from the STAAD Pro. This is one feature of this software. This has other features also, like it can give you the node wise reports, the beam wise reports. If for analysis on, if we configure it here, then it will write the shear force, bending moment values, and bending stress values also from the analysis file to the AutoCAD drawing. In this system, we can open the STAAD file in Notepad, and we can change and rerun it. We can reanalyze, and we can do the free run, and we can get the auto optimization situations. And when the datasheet server is connected, then it can do these separate things. And for nesting, we can directly do a wastage calculation report for the first drafts of the multiple different kind of drafts, and we can fetch the data from previous STAAD optimizations in the datasheet server, and from that we can check the differences and deviations, and we can convert it with the MBS and MBS to STAAD. And these are the separate features. These are all separate features, and all these features are not available directly without datasheet server. So we have these features with the datasheet servers, but without datasheet server we can use these two things mainly, and these two things are mainly for without datasheet server we can handle these things. And for the separate ERP systems, we can fetch these data if we have the credentials, then we can fetch this data and can do the reuse of the materials which are unused in the production server. We can pull that and we can reuse that in STAAD Pro, and we can generate a separate STAAD file with the reused materials which are already there in the material handling departments. And these are the normal features and facilities. Here we wanted to show you only this feature right now. In separate video we will discuss about other features. Thank you.